guys, Mr. Backerberg here. In this video, we're going to work on finding angles inside and outside of a circle. Our first property that we're going to talk about deals with having a tangent line and a chord intersecting on the outer edge of a circle. And if that happens, then the measure of each angle is exactly 1/2 the measure of the arc that it intercepts. So in this picture, we've got a tangent line and a chord intercepting at point B. Now this creates two angles. I'm going to label the angle on the right-hand side angle 1, and the angle on the left-hand side I'm going to call angle 2. And our property says that each one of those angles is exactly half the size of the measure of the arc that it intercepts. So if we're looking at angle 1, then it is exactly half the size of the arc that it intercepts. So it intercepts the arc that runs from A directly down to B. And then if we look at angle 2 on the left-hand side, that angle intercepts the arc that runs from A through point C down to point B. So this angle is half the measure of the arc that runs from A to C to B. Now in this example, we've got our tangent line and our chord intercepting at point E. We're told that the arc that runs from D directly to E is 130 degrees. So based on that property that we just talked about, we said that this angle has to be half the measure of the arc that it intercepts. So in this picture, angle 1 has to be half of 130 degrees, which is 65 degrees. Now we can also use this to help us figure out some more information about our picture. This tangent line is a straight line, so these two angles, angle 1 and angle 2, have to be a linear pair and therefore supplementary. So being supplementary means that they have to add up to 180 degrees. So if we know that angle 1 is 65 degrees, then angle 2 has to be 115 degrees in order to get those things to add up to 180 degrees. And then if we have the measure of angle 2, then we can figure out the measure of the arc that runs from D to F to E. Again, because the measure of the angle is half the measure of the arc, if we wanted to find the measure of the arc that runs from D to F to E, I'm going to take the angle that intercepts that arc and double it. So this has to be a 230 degree arc. Now we're going to deal with some more intersecting lines with circles. So let's say we have two lines that intersect a circle. Then there are three different places where those two lines could cross each other. The first place is inside of the circle, the second place is on the edge of the circle, and the third place is on the outside of the circle. Now we're going to deal with the first case where the intersection point happens inside of the circle, and the last case where the intersection point happens outside of the circle. So first let's focus on where we have the intersection point happening inside of our circle. So if we've got two chords that intersect inside of a circle, then the measure of each angle is half the sum of the arc that that angle intercepts and the arc that its vertical angle intercepts. So let's first look at angle 1. If we want to find the measure of angle 1, then what we're going to do is 1/2 times the sum, so we're going to do a little adding, of the arc that it intercepts. So angle 1 intercepts the arc that runs from A to B, and the arc that its vertical angle intercepts. So the vertical angle would be down here, so that angle intercepts the arc that runs from D to C. So if we want to find the measure of angle 1, we look at the arc that it intercepts and the vertical angle's arc, add those things together, and then multiply by 1/2. So the angle is half the sum of the arc that the angle intercepts and the arc that its vertical angle intercepts. So in this example, we've got two chords intercepting inside of a circle, and we've got the measure of the arc on the top left as 120 degrees. The arc on the bottom right is a 140 degree angle, and we want to use that to help us find the measure of this angle X in the middle. So the property that we just talked about said that the measure of the angle is equal to 1/2 times the sum of the arc that the angle intercepts, so that's our 140 degree angle, and the arc that the vertical angle intercepts. So that's our 120 degree arc. So first thing that I'm going to do is add the two values inside of the parentheses together. So we've got 1/2 times, if we take 140 plus 120, we get 260. And then half of 260 is 130. So that x angle in the middle is 130 degrees. Our next property deals with lines that intersect outside of a circle, so this can happen for tangents and secants. The property is that if we're looking for an angle created by two lines intersecting outside of a circle, then what we're going to do is take 1/2 times the difference of the two arcs that are intercepted by our two lines. So again, we're going to look at angle 1. If we want to find the measure of angle 1, then what we're going to do is 1/2 times the difference, which means we're going to be subtracting, of the two arcs that our angle intercepts. And what we're going to do is we're always going to take the biggest arc minus the smallest arc. So in this picture, the biggest arc is the arc that runs from A to B. And then our smaller arc that's intercepted is the arc that runs from C to D. So if our intersection point happens outside of our circle, then we take 1/2 times the difference of the two arcs that are intercepted. So in this example, we're going to look for our x value. We're going to find the measure of that angle. And the property that we just dealt with said that if our intersection point is happening on the outside of the circle, then the angle is 1/2 times the difference of the two arcs that are intercepted. So the big arc is 178 degrees, and the little arc is 76 degrees. Now if we do that subtraction inside of our parentheses, we end up with 102, and then half of 102 is 51. So this x angle in our picture is 51 degrees. The angle is 1/2 times the difference of the two arcs that are intercepted. That's going to be it for this video. Thanks for watching.